Thank you.
Thanks, everyone. I'm delighted to be here on behalf of the team from Ascribe Bioscience. We're an Ithaca, New York-based company, really looking to revolutionize the way farmers protect crops from pathogens. Pathogens are a huge problem, not only for farmers, but they're a real threat to the global food chain. It's estimated that as much as 25% of the harvest each year is destroyed by non-insect pathogens. This is despite many billions spent on pesticides, nearly 20 billion a year on chemical fungicides alone. So where's all of that money going? The current state of the art here is to use synthetic chemicals that kill the pathogen. So these are products that are toxic by design, right? They're designed to kill fungal pathogens, microbes. I think we all know the negative impacts of that approach. The one I really want to focus on is the effect on the soil. If you're putting products on the farm designed to kill fungi and bacteria, that has a huge impact on the soil microbiome. And so, it's fighting one problem with another, in essence. There are better products on the market, or products that are safer for the environment, better for human health. These are live microbes, complex mixtures mostly, but unfortunately they're not a complete solution. In many cases, these products are too expensive for broad acreage farmers. They also have issues with reliability and compatibility with the practices that farmers are already using. So their impact isn't nearly as great as one might hope it could be. This really leaves farmers that are growing broad acreage row crops, commodities, which really represent the majority of agricultural land, with no really good solutions. And similarly, for growers around the world that can't necessarily afford to spend enormous amounts on pest control, there are no good solutions today. So Ascribe is using natural small molecules to develop biorational solutions to combat pathogens that really rely on the abilities of plants. And what do I mean when I talk about the abilities of plants? I think most of us tend to think of plants as being very passive, sort of these helpless creatures. They sit there and come what may. In fact, and as demonstrated by this video, plants have evolved remarkable systems to sense threats in their environment. And they actually have defenses that they can rally to protect themselves when there is a threat. It's this property of plants that really underpins Ascribe's technology and the products that I'll tell you more about. Our first product is a biopesticide called Phytalix. Phytalix, it's very much like a vaccine for plants. So our product is based on a naturally occurring small molecule. It's produced by a plant pathogen that lives in the soil. And plants have evolved to sense this molecule at really minute levels. And in essence, this acts as an early warning signal to the plant that there's a pathogen about and that they need to protect themselves. So they respond to this molecule by priming their innate defenses. And the consequence of that is that the plant, once primed, is able to fend off pathogens at the earliest stages of an infection as they arrive. Importantly, this product has a completely non-toxic mode of action. We're really relying on the abilities of the plants to fight these pathogens. We're not killing anything. And so that has a huge impact on soil health. We're not destroying the soil microbiome. We're actually using something from the soil microbiome to help combat these problems. Because plants have evolved to sense this molecule at such low levels, we can apply it at incredibly low application rates, which has further environmental benefits. And then finally, it's important to note that though we're using the plant's defenses, we're priming those defenses, not activating them. And so this doesn't slow plant growth or cause any yield drag. The product works on every crop that we've tested so far. It seems to be a very ancient evolutionary adaptation within plants. So all plants respond, and we get a remarkably broad spectrum. We can protect plants from fungi, bacteria, viruses, nematodes, and it just really uniquely broad spectrum. Our focus, our beachhead markets for this product are wheat and soybean growers, and we're specifically focused on the fungal pathogens that those farmers deal with. We've seen really compelling activity in the lab for these pathogens, and this past year we have dozens of field trials out across the country and in Canada with, again, a real focus on wheat and soybean. I want to pause on this slide for a minute just to be sure. So in these trials, we're performing as well as best-in-class fungicides to control Fusarium head blight, which is one of the most damaging pathogens in wheat. And frankly, I think even we were surprised that we get this level of efficacy. And just to drive this home, our application rate of Phytalix in the trial shown here is 25 milligrams per acre. That's less than the weight of a single grain of wheat across an acre of crop. And that's compared to Prosaro, which is a best-in-class Bayer chemical fungicide. In this particular trial, Prosaro applied at the label rate is 5,000 times the application rate of Phytalix, and yet just using the power of plants, we're able to compete head-to-head with that product. Importantly, Phytalix is easy for farmers to use. So unlike some of the biological products that I mentioned that are either unreliable or difficult to integrate with existing practices, this product is incredibly easy for farmers to use. It'll be affordable, it can be easily combined with other products, we can apply it as a seed treatment or a spray, and this priming impact on the plant lasts for weeks after an application, so there's a lot of flexibility for the grower in terms of when they apply the product, and potentially even the ability to avoid additional applications of pesticides during the growing season. In addition to our own trials, we did a number of trials this year with large-scale growers and potential commercial partners, and they're seeing the same benefits that we saw. So a lot of excitement in the marketplace from people who have gotten their hands on this product early on. So really, what we envision for the future of crop protection, I think, is driven home by this slide. So based on that application rate that I talked about on the field trials, an amount of this product equivalent to a single aspirin tablet will treat 15 acres of crop. Today, that requires more than 3.5 pounds of toxic fungicide to do the same thing. So Phytalix also promises to be good business. I mentioned our beachhead markets for the product are wheat and soybean. We think we can easily achieve $100 million sales in that market segment alone. US farmers for wheat and soy spend over $1 billion a year. And that's really just the beginning. That doesn't include all the other crops that we can treat or the global market. So where are we in terms of commercialization? First, it's important to note that this is patented technology. We have issued patents in the US and Europe. We've developed an efficient manufacturing method for this active ingredient. As I mentioned, we have great field validation from this year and multiple commercial partnerships underway. We also have the team and resources we need to get this into the market and have an impact. In addition to a great technical staff, we have a world-class advisory board, an experienced leadership team, and we just raised a $2.1 million seed round to accelerate commercialization of Phytalix. So before we launch this product as a biopesticide, we need EPA registration in the US. So we're already on track to do that, but we're anticipating a market launch in 2024. Given the activity and spectrum of this product, we can easily achieve $10 million revenue within a couple of years and rapid job growth throughout that process. This is technology that was discovered here in the Grow New York region. This is based on innovations and discoveries at the Boyce Thompson Institute for Plant Science and Cornell. We have deep collaborations already within the region. And we're poised to build a manufacturing facility to start pilot manufacturing in 2022. We want to do that here in the Grow New York region. We've also started looking and collaborating with people that can help make an impact with this technology for New York growers. So we have a collaboration with Cornell Agritech to look at the ability of this product to control viral pathogens in grapes. and have been working with Intergrow on tomatoes. So in terms of Grow New York impact, with $1 million, we will build that pilot manufacturing facility. We'll accelerate field trials for additional crops more meaningful to New York, and we'll begin to fill our pipeline with additional products. What do I mean by that? Phytalix, as I mentioned, it's from the soil microbiome. It's estimated that a single handful of soil contains 50,000 species of microbes, many billions of individuals. The chemical diversity that's represented there in terms of all the small molecules is truly astounding, and it's really untapped. So we really think Phytalix is a proof of concept of this broader concept of mining the soil microbiome for small molecules that can make agriculture more sustainable.
Okay. Thank you very much. That's a great pitch. We got 9.5 minutes for questions. Let's get it over to the judges. First up, we got Laura Peterson.
This sounds great, almost too good to be true. I'm sure you thought that too when you were seeing the results. Did you do any replicated trials over a large area with some control as well, with managed by maybe universities, or was this all like one field here and one field there?
No, absolutely. So the trials were a combination of contractors, so the contract farms that do trials for all ag companies, as well as some large-scale growers and potential commercial partners. And in each case, these are well-designed trials with randomized plots, negative controls, positive controls. We always put the product up against the best-in-class existing chemical product for the pathogen of interest. And this, I didn't mention, but this is our second year in the field, actually. So in 2020, we also did, sort of preliminary proof of concept field trials. A big question for a technology like this is that it may work great in a greenhouse under controlled conditions, but what happens in the field? And so we got that validation in 2020, and then this was really much more extensive field trials this year, and we'll further expand that in 2022.
Do you think this could be certified organic?
Yes, but as we're bringing it to market initially, it will not be, and that really has to do with the way it's manufactured. So to be certified organic, we make the product by chemical synthesis. We use some plant-based starting materials and a process to make the exact same molecule, but that product won't be organic, but we have alternative ways to manufacture it that would qualify organic. It's worth noting, though, for I think the acreage under organic production today is about 1%. And so while we think that's important, we're really excited to have an impact on the other 99% of that acreage. So.
Let's go over to John Catapiano.
Yeah, really interesting here as a person who's got the background in farming and in the soil and like where this has gone. And you actually answered one of my original questions. I was thinking about the competition, but you answered that with Protero versus Phytalix. I guess what you didn't specifically answer in that comparison, some of the price points. While you talked about the effectiveness, how do you see your price points versus a competitive product like that?
Yeah. So just for reference, Prosaro and products like it, I shouldn't pick on Prosaro specifically, but a best-in-class chemical fungicide for these broad acreage growers, they're about $20 per acre. We've built all our financial projections on a cost to the farmer of $5 to $6 an acre. Because our application rates are so low and we can efficiently manufacture this, we have a lot of flexibility in terms of the pricing. And so we've taken kind of the middle road as a conservative first estimate. I think, if we continue to beat those products that are already at $20 an acre, so it's affordable is the short answer.
Great. Okay, let's go over to Annie.
Two questions, but I'm going to loop it hopefully into one. So to me, this is almost like you're creating an immune response in the plants. You are initiating that response as protection. Can you overstimulate that, causing negative impact? Going from putting a barrel of pesticides on versus, an aspirin tablet I can imagine application challenges. So
Yeah.
could you ask that?
Yeah. So the first question on over-application, there is a subtlety here in that there are other products on the market that activate plant defenses as a mechanism of action. And many of those products actually, one challenge they face is that when you activate the plant defenses, that costs the plant energy, right? So you're diverting energy away from fruiting or further growth toward this defense response. This molecule is special because it's priming those defenses. It's not actually activating them, so there's no immediate cost to the plant. So that's part of the answer to your question. I think the other piece is, well, what happens if you put way too much on? Do the plants just go crazy? And it turns out they just don't respond. I think if you overwhelm them with a signal, then the plant ignores it because maybe it just figures, well, there's nothing I can do about this. The second question about application is one we get a lot, right? So you show that's great. An aspirin tablet treats 15 acres, but how do you do that, right? And the answer is we formulated this to be easy for the farmer to use. It's water soluble, so what gets delivered to the farmer is going to be very familiar. You dilute this at 1 ounce per acre into your mix tank, and you're good to go. So yeah, there isn't a challenge there.
Great. Thanks, Annie. Over to you, Mary.
Hi, Jay. Yeah, this is really exciting. We're coming out of the seed industry and having brought a product to market. Kind of going back to what Laura said, it's that big jump from greenhouse to field is one thing, but another thing is field from years to years to years. And I know you don't have that yet. But just thinking about the trials that you had this year, you said there's a lot of excitement about the results. So tell me about some of the positive surprises or the positive results, but also were there any negative surprises in terms of those trials?
Yeah, so I think a lot of our excitement comes from the consistency. As I mentioned, we had several dozen trials out. Those were, really spread across the country. If we put them on a map, it's like darts. And what we saw was the same pattern repeating again and again. We'd see similar level of control, and we'd actually see the similar comparison. If we had the same chemical fungicide side by side, we'd see the same ratio. So that's really encouraging as a scientist because it tells you this is not random noise. This is a repeatable phenomenon. In terms of challenges, 2021 was a horrible year to do field trials, as it turns out, right? I mean, incredible drought, heat waves, and I guess the silver lining there is that, well, a lot of the trials were just destroyed outright. If drought kills your plant or there's no humidity so that the fungi that you're trying to control just never show up, you get no data. But we also got a lot of data that there is no downside, and the data have yet to come in, but in some crops there may even be some effects with abiotic stresses. But really, it was more the weather than anything else this year.
Great. Okay, question from John Eng.
Hi. Is there, or do you know of a multi-year effect? A farmer applies it once, gets 5 years effect. Do you lose a customer after one application?
Yeah. So that's a concern for some microbes, right? Because if the microbe can thrive in the soil and it helps plants, you apply it once and it's there. In this case, it's just a molecule, and it's actually biodegradable. So if we put this on a plant or a field, and come back 2 or 3 days later, you can't find the compound. So the signal it activates the plant, and then it's gone. So there'll be no holdover in that regard.
So do you need a multiple applications throughout the season?
I think it's going to depend on the crop and the pathogen. We have data that show that the defense priming can last up to 6 weeks. I think to take wheat as an example, we control 2 fungal pathogens really well. One of them is an early season soil-borne pathogen that causes damping off, where the seedlings kind of die early on. And for that, the seed treatment works fantastically. But Fusarium head blight, the data I showed you, that was by spray kind of mid-season once the wheat plant is up. Fusarium head blight comes just as the wheat is flowering and starting to mature its seed. We don't think a seed treatment is going to last that long for Fusarium head blight. Next year's field trials, that will really interrogate You know, that's part of the excitement actually about this year's field trials. We haven't even begun to turn the knobs to optimize this, right? We put it out in the field kind of with our best guess based on the laboratory, and it's already working great, but we can probably make it better.
Great. Well, I think we're out of time.